Hi everyone. In this video, I want to update you on the work that I've been doing with this Kuzu database. Kuzu is a graph database, and as it says here on their website, it is embedded, it's scalable, and it's blazing fast. Kuzu is also really easy to use because it has a Python interface, so you can pip install Kuzu and start working with it. I have integrated Kuzu into topologicpy by adding a Kuzu.py module that has a Kuzu class and other classes in there that help you convert between topologic graphs and Kuzu graphs. So let me show you the workflow and the Jupyter notebook for that. If you have landed on a older version of this video, please ignore that because I have updated the methods and the API has changed slightly. Okay, so this is the Jupyter notebook. This Jupyter notebook is called kuzu.ipynb, and you can find it also on GitHub under the notebooks folder, the GitHub for topologicpy. As usual, the first cell is something that you don't need to run simply because I'm on my developer machine, so I will run that myself. But you start from the second cell, which imports all the needed topologicpy classes. So that is now done. This second cell checks the software versions, and as of the recording of this video, we are at 0.8.58, and the helper.version method actually you can set check equals true, and it will check whether your version is the latest or not. If it's not the latest, please do upgrade because this will not work with anything before 0.58. Here it says topologicpy version. The version that you are using, 0.8.58, is equal to the latest version available on PyPy. Great. So we're going to create a sample graph. This graph is made from a cell complex that has 3 sides. So let's go ahead and see that. So this is the graph. And as you can see, the vertices are labeled, and the graph itself has a dictionary, as you can see here, where we have graph ID and the title, and the graph ID is 1, and the title is called a sample graph. And then every vertex has a label with a numeric value. Okay, so we have this sample graph. In order to create some extra graphs from it, and this is also a new version, a new method in this version, this is called an induced subgraph. An induced subgraph is basically a subgraph where you pick certain vertices, as many as you want, and it will create a graph out of those based on the existing edges. And you can choose whether you want to be strict or not. If it is strict, if you set strict to be true, the edges have to be between 2 of the selected vertices. If strict is false, only one vertex needs to be present for the edge to be included. So try it out and see what you get. Obviously, I'm choosing a random list of 10 vertices here, so every time you run it, it might give you a different result. But you can see in this case, I chose these 10 vertices, and it showed me the edges that are both connected, that are connected between them. And you might get isolated vertices, for example, if the edges are do not connect between 2 existing vertices. Another way to create another graph is to create what is called a k-hops subgraph. Basically, what that does is you choose a list of vertices, could be just one vertex, and you specify a k, like a hop, how many hops, and basically from that vertex it will do a kind of almost like a walk. It will find the neighbors and then the neighbors of the neighbors. So in this case, it will do 2 edges or 2 hops, and it will assemble all these vertices and create for you a subgraph. So let's just take a look at that. So this is 2 hops out of vertex number 1. As so you can see here, it goes to 5 and then to 4, or it goes to 5 and then back down to 27, or it goes to 23 and then to 27, or to 23 and then to 20. So it's 2 hops. As you can see, everything is exactly 2 edges away from vertex number 1. So that's a nice way also to get subgraphs. All right, so let's focus now on the Kuzu database itself. So what changed from the previous video is that I no longer pass along the path every time, because it was a bit inefficient. So now I create a manager and then I pass the manager around. So just take a look at the API documentation. But let's start from the beginning. So the first thing you do is you specify a database path of some sort. This path usually ends with .kuzu, and if it doesn't exist, it will create that file for you. So definitely, if you're using this Jupyter Notebook, go ahead and change this path to match your computer. Right, so you specify a path to where you would like to save the Kuzu database, and you create a manager. So in this case, we're calling it manager equals kuzu.manager db path. So let's run this. And now that we have the manager, that manager gets passed to all the other Kuzu methods. So the first thing we're going to do is we're going to empty this database. And this is important if you are repeating this Jupyter Notebook again and again. You would like to always start from scratch, from an empty database. So a good first step is to empty it. So now it says it has been successfully emptied. So now what we're going to do is we're going to upsert, and upsert is a portmanteau of update and insert. It's like a combination of those 2 words. Basically, if there is an existing graph with the same ID, it will delete it and replace it with this new graph that you are uploading, or if it doesn't exist, it will insert it, it will add it. So we are upserting the sample topologic graph and a subgraph to the Kuzu database. So we're upserting two graphs. So graph ID 1 is kuzu.upsert graph. We'll give it the manager, and we're upserting the sample graph, the big one. And we're giving it, we're telling it that the graph ID key should be called graph_ID. And we're upserting the subgraph, and we're calling that, that's going to be ID2. Of course, it will get a new ID. And it has its own ID in its dictionary. So graph ID 1 has been upserted, graph ID 2 has been upserted, so we are done. We have 2 graphs. So let's go ahead and list them again to make sure they are there. And here they are. The Kuzu database contains 2 graphs. So you can use kuzu.listGraphs and give it the manager. And these are the actual cards. We call them like a card, or it's an index of the graph. The ID is 1, the label, it has no label for some reason. I'll have to take a look at that. Number of nodes, 27 in this case, and 54 edges, and the other one has only 12 nodes and 16 edges, because it's a subgraph. All right, so now we can also get the graphs back through their ID and rebuild a topologic graph. So graph IDs is equal to card ID for card in cards. So we get all the graph IDs. And we go ahead and loop through them, and we say kuzu.graphById. We give it again the manager and the graph ID. We append them to a new list, and then we show that graph at that point. So here's the first graph, and here is the second graph, exactly same as before. So let's check the dictionary, make sure everything is there. Yep, it has a graph and a graph ID and the title. It doesn't have a label, that's why label was none. Usually there should be a label. And we check the vertices as well, and they're the same. We can also sort by label. Let's put it in double quotes. So we can have them sorted by the label number, like this, but obviously, that did not work very well. Oh, because there is no 2. Okay, I see, there's no 2. So it's sorted at 1, and then the 20s, and then 3, 4, 5, 7. That is probably because this is the subgraph, right? So let's do the sample graph, which is 0, new graph 0. And yeah, that's it. Unfortunately, as you know, it goes 1, then the 10s, up to the 19, and then the 2. So the sorting is not very, very good unless you put preceding zeros to make it sort correctly. But yeah, we can sort. We can invent a good key for sorting. And let's check the dictionaries of the edges. And those are also fine. We're sorting by the label here, and we are reversing the sorting, so it goes backwards. And that's it, really. One thing I would like you to try on your own, and it does work very well, but I don't have the ability to show it for you here, is to actually get graphs from a CSV file and upload them to the Kuzu manager. If you've been following the videos on machine learning, you know that Topologic can take all your graphs and output them to a set of CSV files, and those are compatible with PyTorch, so you work with PyTorch geometric, so that you can do graph machine learning on them. Those same CSV files, the same column header, same kind of folder structure can be loaded here, and you can create Kuzu graphs out of them. So the way to do it is simply you call Kuzu by CSV path. Again, you give it the manager and you give it the CSV path to the folder that contains that. And let me very quickly show you what that looks like. Like in this case, I have this folder called 1, and in this folder has edges, graphs, a YAML file, a meta.yaml file, and the nodes CSV file. Those are exactly what you find on GitHub as well, under resources, I believe, where you have this machine learning CSV files. You can try those and load them up, like let's say our building ground relationship dataset, which is called the BGR dataset. You can try to load that into Kuzu and make it a Kuzu database out of it. That's it. If you have any questions, please don't hesitate to contact me over email or on social media, and I would be happy to talk to you and answer your questions. Thanks again.